Hey everyone, welcome back to part 3. Let's finish up this lesson on trig equations. Okay, so on this example we let m equal cosecant, and now we're at the stage where we want to factor this quadratic. See how it's m squared, m and a number? So we're going to factor this quadratic equation. And this one's a fairly straightforward factoring, m squared, m times m, and then we're looking for two numbers that multiply to negative 28 and add to negative 3. So numbers that multiply to 28, let's be methodical if you can't think of it right away. 1 times 28, 2 times 14, 3 doesn't go in, 4 times 7, there we go. So 4 and 7 have a difference of 3. That will give us the middle number. We need opposite signs, so we want 3 to be negative, so negative 7, positive 4. Okay, and rather than sub cosecant x back in right at this point, we're just going to solve for m first. So using zero product law, we would set each factor equal to 0 and get m equals negative 4 and m equals 7. Okay, now let's replace m. We had let it equal cosecant x, so cosecant x now then would equal negative 4 and cosecant x equals 7. All right, now we would, let's see, cosecant, we better change that to sine. So sine x, what we did was reciprocal the left side, so we reciprocal the right side. Same thing here, we're going to write that as sine x equals 1 over 7. And there we go. Those do not look like exact value coordinates on the unit circle, so we're going to need to bring up the calculator and we'll calculate what this would be. Okay, let's do that. So we want to do, oh, look at that, it's already there on the calculator. So we have the inverse, what mode should we be in? Check your domain. So it looks like we should be in degree mode, and they want it to the nearest degree. So first, inverse sine of 1/7, that would be how you get the reference angle here, 8 degrees. Inverse sine of 1/4. And we just skip the negative because we're trying to find the reference angle, and you get 14 degrees. So let's write that down. So the reference angle here would equal 14 degrees, and the reference angle here would equal 8 degrees. Okay, so let's draw each of these. So we have, first of all, go back to here and you look and you go, okay, sine, which is y, is negative. So where is y negative? And that would happen down in quadrants 3 and 4. Our reference angle here for both of those is 14 degrees. So we need oh, look at our domain, 0 to 180. So both of these angles, the rotation angle, would be outside of this domain. So as a result, this one doesn't give you any answers. We can leave that one. Okay, let's go back to this one. So again, sine, which is y, is positive. So that would be in quadrant 1 and 2. Which means our reference angle here, 8 degrees and 8 degrees. Our rotation angle, x, is going to be, well, first of all, 8 degrees. And then the other one would be basically all the way to 180 minus 8 degrees would be 172 degrees. And there we go. Those would be your answers for that domain, 0 to 180, answer to the nearest degree. Okay, let's take a look at this last example. Okay, we have g of theta. So when we're finding zeros, we want to set y, or in this case, g of theta equal to 0. So we would have 2 cos squared theta plus 5 cos theta minus 3. Okay, so it looks like we have a quadratic here, right? Cos squared cos. So let's replace cos. Let's say let m equal cos theta. So this would become 0 equals 2m squared plus 5m minus 3. Okay, so we're going to factor that. Whatever method you find works best for you, you should factor it that way. I like this method, 2m divided by 2 multiplies to negative 6, adds to positive 5, 6 and 1, positive 6, negative 1. And again, if you need to review this, go back and look at the lesson on factoring. Okay, so 2 will divide into this one. If we factor the 2 out, which would be 2 and then brackets m plus 3, now that common factor can divide, and we have 0 equals m plus 3, and 0 equals our other factor using our zero product law. Solve each one for m, and we should have m equals -3 and m equals 1/2. Okay, let's put cos theta back in to both. Okay, now to this one, cos theta equals -3. Okay, so you probably don't recognize this. You can try it on the calculator if you like by going reference angle equals the inverse cos of 3, but it doesn't really matter because you're going to get an error, right? And the reason why, there's two ways to think of this. You could think unit circle, and the biggest a value can be is 1, or the smallest -1 for cosine, or go back to cosine being adjacent over hypotenuse on a right angle triangle. Okay, can the adjacent side be 3 times the hypotenuse? No, you can't have that. The hypotenuse has to be the biggest. So therefore, this one doesn't give you any solutions. Okay, so no solutions. That looks weird with that 3 there. Okay, no solution for that particular branch. Okay, but let's continue with this one. So cos theta equals 1/2. That sounds like unit circle to me. So where cos is, which is x, is positive, would be quadrant 1 and 4. And little, that's the 1/2, would be in these two locations. Okay, so theta, oh, look at our domain here. Okay, we need to describe it between -pi, which would be all the way to here, and +pi, which would be to there. So this first angle would be basically theta equals, that's a huge chunk of pi, so pi/3, but negative direction because we went clockwise. And then the other angle is actually in the positive direction, and it would be +pi/3. And there we go. Within that domain, -pi to pi, those would be our two answers. Okay, good job everyone. Hopefully the assignment goes well for you tomorrow in class, and thank you for listening.